Hello, and welcome to AI Time Journal podcast. My name is Senthujan, and I'm here today with Praneet Dutta, a research engineer at Google Deepmind. Today, we're going to talk a little bit about his background, his job at Google Deepmind, and his future career aspirations and directions. So to start things off, Praneet, why don't you give us a little bit about yourself, your background, your education, and what made you decide to pursue an education in artificial intelligence?
Yeah, of course. And thanks for having me, Senthujan. It's really nice talking to you. So yeah, I can quickly get started a bit about me. So I'm a research engineer at Google DeepMind. I'm based in Mountain View, California, and my broad role is in working towards artificial general intelligence, which by itself is quite exciting. A bit just to go a bit back, how did I get here? I guess a nice place to start off is from university. I did my undergraduate studies in India. I was at this university, Vellore Institute of Technology in the southern parts of India. I did my undergrad in the area of electronics and communication engineering. So not too much, I didn't start off thinking that, oh, I'm really going to specialize in AI. That's just part of the story of how this happened, which I'll explain right now. So yeah, I started undergrad in 2012, and I was not sure, honestly, in what I wanted to do. Like, at that point, you're just starting off, and you're like, oh, I'm in college, and you're like, let things happen. So a lot of people saying, oh, do you want to? Some people want to do an MBA or go down the formal business route. Some people want to get a job. Some people want to pursue PhD. Some people want to do like something totally different, like get into aviation. A few of my friends have become pilots. It's quite amazing. So I wasn't quite sure. So in my first year of undergraduate, I joined this interesting project where it's called Formula Student. In this, the university students they used to build form, well, it's not obviously not full Formula scale because it's quite expensive and involves a lot of full-time dedication from a lot of trained professionals. But it's a Formula version of student scale version of these competitions where students build these race cars, and then they go to these competitions across the world. I think the major ones are in Europe, and well, they compete over there across a variety of different tasks. So through this competition, I worked as an electrical engineer, given my background. Honestly, I felt it was quite hard to manage, given we used to attend classes in the morning and then work in the garage at night. So during the time, I was working electrical engineering system, mostly wiring harnesses, soldering, and all the other stuff, with the circuit boards. So a very close friend of mine was in the powertrain system of the team, and basically working with the engine and trying to tune it so it performs better across the different racetracks globally where we hope to compete. So I had to see him struggling quite a bit with like trying to tune the engine, try to make sure it performs the best, and using these simulation softwares to see how it do given certain input parameters. And this was, I think, during my second or my starting of my junior year actually. Yeah, so once I just went up to him and said, hey, I'm doing this really cool course on machine learning. It's by this guy called Andrew Ng on Coursera as a professor at Stanford, and it's pretty interesting. And I saw the idea of perceptrons that are good, universal function approximators back then, but it was pretty new to me. So I told them, I see that you're spending a lot of time on simulations, and you're struggling quite a bit with setting it up correctly and learning good function approximation. Here's a crazy idea. Let's try to throw linear models at it and throw neural networks at it and see how well it does. So he's like, sure, let's do that. And it was kind of a research segue to what we were doing. We were both also at that point thinking of what to do post graduation. So maybe if you can make a research project out of it, that'd be fun. So we started evaluating these models, and then yeah, we got pretty preliminary basic results, as you can imagine, from two people who can't code, but we just tried to patch something together. But the faculty, I mean, were quite supportive. We presented this internally at undergraduate conference. We won a small prize. So like, yeah, that's great. We kind of extended the paper, tried to get some advice on how to write research, because we were at that point just bootstrapping. So we tried to write a formal paper, and very luckily at an IEEE conference back then in London, it got accepted. And that was great because we got to travel and see other people publishing. This was my first time at a conference presenting my work, and getting to see like, real researchers, who have dedicated their lives currently working on this field was quite exciting. There's a lot of work in the medical field, finance, automotive like ours. At that point of time, I kind of realized that this is what I want to do and decided to pursue graduate studies. Um, I joined Carnegie Mellon's graduate program in electrical computer engineering. Basically, took a lot of courses in machine learning, computer vision, and a few in multimodal learning. Spent 2 years, 1.5 years there. Really liked it. Did an internship at a game engine company, Unity. Is really cool. I joined Google after graduating, and I can talk more about that later on. And I was in Google for almost 2 years till 2019 December. And then in 2020, I joined Deepmind, and I've been here since.
Amazing. That's a very interesting background. I want to point out two really interesting things that about your background is first, you follow a trend of a lot of applied engineering students who pivot towards the machine learning, artificial intelligence space. I see that trend happening more and more. I think it's that fascination with robotics and seeing how machines and seeing how equipment work that really resonate with the predictive capabilities of machine learning and using that to help automate certain functions. Another thing that I found really interesting about your background is your initial lack of coding experience. I think there's this misconception that you need to be proficient coders or need to be a trained software engineer or computer scientist to get into the machine learning space. But as you can see with your background, you're now a research engineer at Google DeepMind, working very heavily in the machine learning industry, and you picked up those coding skills as you went and as you progressed throughout the different stages. So I think once you have a strong concepts of the machine learning foundation and the artificial intelligence concepts, right? The coding comes naturally. And those are skills, those are very technical skills that can be picked up as you progress throughout your career. Do you agree with that?
Yeah, it's an interesting thought, and I've been thinking about this quite a bit because I work with a lot of really strong researchers, engineers, closely working in this field, and there's a lot of diversity in backgrounds. Like not everybody has a formal CS degree or CS PhD. They've all come from a variety of different backgrounds. Some from electrical engineering, some even non-engineering. Some from I remember my mentor at Unity. He had a psychology PhD. It's just really mind blowing because I think he picked it up on his own. So yes, I do agree that a formal education is not necessary to get into the field and start dabbling it on your own time. Of course, different companies have their own requirements. I can't speak for that. But that being said, if I would go back in time, I would invest my time and assuming I want to work in the AI field, I would invest my time in a few other resources apart from just purely picking up some of the just trying to run off the shelf algorithms, right? Linear algebra, statistics, probability theory, that is quite essential to really understand the maths behind what's going on in all these algorithms out there. So that's something we're really strong in. In my case, luckily, studying electronics engineering, I go to study a bit of probability theory backs up that was covered. But if you don't have a maths background, I would definitely recommend that. The second is also software engineering skills. Now, in my case, that was a bit hard, but I guess doing a few basic courses on like how Python works, the best programming practices and all, it's quite important. There's a lot of focus right now on ML ops these days and like having clean, readable code and being able to maintain them well. And coming from a background like mine, I feel I would invest, if I invested that time, I would have saved a lot of time in like cleaning up my code base and making it more readable, functional, and usable for production purposes. So of course, being at big tech companies, you're able to learn from much more experienced engineers and follow good coding practices. You have all infrastructure set up, but having that proactively done, I think, is a big advantage. And I guess the third thing, I think, and again, all of these are easier for like students, but even if you're a professional, there are tons of courses out there on these. So yeah, you can learn how you want to pick it up. But yeah, and the third thing was also like understanding a bit of distributed systems. And in the machine learning field right now, we are seeing a general trend we are seeing right now is like bigger and bigger models. And then that as a result of that, we also get to see like larger infrastructure used to support them, not just for training, but also, inference, sort of federated learning and all as well. So also understanding computer infrastructure, running models on the edge. That's something which I would recommend people also study a bit about to understand what's going on behind the scenes.
Amazing. Thank you for those recommendations. Our viewers will really appreciate that. And while we're on this topic of coding and different packages that you're using, I wanted to ask you, what are your favorite packages to use, especially when you're doing predictive modeling?
Yeah, that's a good question. So when I started off, as I did the Andrew Ng course. So that course, at least back then, was based on MATLAB or an open source version of it called Octave. So um, that had a lot of nice libraries there for like vector manipulation and computing gradients and all of that. So that, and I think also a few nice image processing libraries in MATLAB too. But yeah, I started off with that. But then this was around 2014, 2015. At that point, a lot more was going on in the Python world because I mean, a lot like TensorFlow and all were getting right big at that point. So I started looking at these courses which had these Python-based as language of instruction, and then naturally the most obvious would come to mind is NumPy and Pandas. NumPy for manipulating data, Pandas for data frames. I mean, obviously they're quite correlated. We have a lot of correlated submodules as well. What I also found useful was Matplotlib, sorry, Seaborn, and then there are a few other visualization packages I also used, which quite important. Scikit-learn, deep learning was pretty big back then, but people were still using the SVMs, regression, kernel-based, other kernel-based methods, Gaussian methods. So yeah, scikit-learn was quite useful. You can just quickly wrap up a model by passing it an input data frame. Yeah, and then there's something I've been using recently. Deepmind has this open source library called Trees, and that works really well with nested data structures. I'm not sure how much your user might find it useful, but it's quite clean, especially you don't have to write these complex for loops, which at least I used to do in the past for like trying to manipulate these complicated structures. In terms of like actual deep learning frameworks, like I also use TensorFlow quite a bit. Back in grad school, I started off with Keras when this was before TF 2.0 and it was less integrated in the main TensorFlow system. So I started with Keras. I found that quite easy to use. But then I started using TensorFlow and like, wow, this is quite neat, especially for production-based systems. So I've been using quite a bit of TensorFlow. I've recently been trying to learn JAX. It looks like it's quite similar semantically to NumPy. So I'm starting to like look into it a bit and see how I might use it vis-a-vis TensorFlow. And yeah, unfortunately, I've never had the chance yet to use PyTorch, but at some point I might try it out and just see how that experience is as well.
So why don't we move a little bit into your professional experience? So as we mentioned earlier in the podcast, you work with Google DeepMind. So I want you to tell me a little bit about that experience, and if you could highlight some key projects that you worked on with DeepMind, and just overall your entire experience working in that organization.
Yeah, of course. Yeah. So, DeepMind, was a really like back when I think when AlphaGo came out, I was like just graduating undergrad. So I was like, wow, that's a really amazing project, right? Like really smart people. And back then I was like, oh, at some point in the future, if I do go into industry, it might be one of the cool organizations for me to check out to work at. So yeah, things panned out. 2020 January, I joined DeepMind in its Mountain View office. DeepMind's based out of, they have a couple of global offices, headquartered in London, but then they have offices, I think, in Paris, in Canada, and the US. So yeah, I joined DeepMind. I'm part of the sub team in DeepMind where we work on many applied use cases. And yeah, the one of the more public ones which I'm working on extending is on where DeepMind technique was used for optimizing Google data centers. So I think they reduced Google data center bills by 40%. So yeah, I heard about that project before joining too, and I've been recently working on this, where we're trying to extend it for other industrial use cases. I've been working on some simulation efforts associated with this. Another cool project I also collaborated at DeepMind for a bit was with a game theory group. And this is an exciting one for those of you who follow football or soccer in the US and Canada. We collaborated with researchers from Liverpool Football Club, and we published a paper on what AI can do for football can do for AI. And it's a pretty interesting paper. It was published in the Journal of AI Research, so you can have a look at that. I primarily worked on some of the computer vision aspects of that, seeing how we can estimate pose and so forth. So that was quite an interesting project. We also organized a workshop. I'm personally into sports quite a bit, and I see the potential where AI techniques can potentially augment players' abilities, like maybe make coaching more effective or help people get insight which couldn't be readily achieved as much in the past. So I'm pretty passionate about that area. So we organized a workshop earlier this year on AI for sports. So again, really great to see the different kind of works out there. And yeah, I volunteer as a TPM for technical program committee member for these niche domains. So it's a great experience to kind of see what's happening over there. Yeah, so these are two of the like public collaborations I can speak about. I also worked a bit on a collaboration between DeepMind and Google Play, where they used where they used their agents to provide recommendations, personalized recommendations in the Google Play Store for users. So I worked on the machine on the infrastructure on that. So it was very interesting to see how these models are set up and served.
Sounds good. So I noticed that you mentioned a few times before on AutoML, and just to give our viewers a little bit of background information, AutoML is basically changing the machine learning landscape. It's basically able to fast track machine learning models through data preprocessing, model development, and even some companies like Data Robots, Databricks, H2O.ai takes your models and puts it into deployment stage. The accuracy of these models are pretty good, and they're able to really handle like tough data processing is challenges like imputation, feature engineering, and etc. And so you can see a rise in these companies and other organizations investing in making AutoML one of their strategic points in their organization. So I want to hear, what are your thoughts on AutoML, and where do you see AutoML playing in the future of the machine learning landscape?
Yeah, that's a great question. Yeah, so I have worked with AutoML in the past, but my experience limited to GCP. I haven't seen what other major cloud providers have. But yeah, I mean, when we talk about AutoML, the term separate from meta learning, what I'm talking about is like a no code sort of a movement. Like when people want to quickly ramp up and say, oh, I have this treasure trove of data, lucky for you. I have in supervised learning paradigm, I have like input features and then have the output label I don't want to build up an model and iterate. Can you provide a solution for that? And I really like that such solutions out there. Google AutoML, I think there might be variants of that, but I'm talking about the structured one, first handling structured data. It's quite great. You can import data from data source, like we have BigQuery in Google, basically like stores a lot of data, but I'm sure you can import it from other sources like CSVs, etc. And you can fit them, you can pass it on to AutoML. It trains a model based on certain specific parameters. You said, how wide do you want the grid search to be? And based on that, it returns a model. It tells you how well it does, tells you the feature importance, what sort of examples. Well, it's been a while since I worked on it, but it tells you a lot of interesting information, how the entire training went, and a lot of insight on your data. So overall, on a high level, I really like it. It allows to get not just the domain experts, but a lot of other people into a field real quick. So movements like these always get a plus one from me, because that's great. It's expanding the net. One thing I would like to point out to people, like generally in machine learning, is your model is, obviously good architectures can optimize performance, but it's only as good as the data you provide it. So it's like if you put garbage in, you can't really expect a really good output, right? So stuff like, data quality, noisy data, missing labels, all of these things really impact the performance of how well your model does. So that's something people should be aware of. There's no magic going on here. It's just learning. It's learning about feature representation from what's being fed into these agents that are self-learned. So I enjoy that. I specifically worked on something cool. So if your viewers want to learn about that, there's one collaboration we had in GCP where for the reinforcement learning use case, there's something called Contextual Bandits. So it's a simpler form of RL where you have a single step. And these bandits are used quite a bit in industry. A lot of big companies using it for recommender systems. Netflix has a nice article how they're using bandits for showing you album artwork. So anyways, in bandits, basically you're trying to estimate how good it is for the to do a certain action. So in recommendation systems, like what item, for example, to show to the user. And you can learn a deep representation that takes in a tuple of a given state. So let's say the user demographics, a given candidate action, and then predict how good this action is versus other state action combinations, right? So it's called a Q function. And we try to see if that rather than us throwing maybe x many layers of neural networks, can we actually use AutoML to figure out the optimal q value and minimize a metric called regret. So that's too much information, but basically just see how well can fit the objective. So we got pretty reasonable results. These were quite preliminary for full disclosure, but we tried to compare it against some of the baselines used on non-AutoML approaches, so like learned models. And it got pretty interesting results on on limited benchmark data sets. So we got a paper out at the Zerexis Reveal workshop in 2019. And yeah, that was quite fascinating. I moved to Deepmind since, so I haven't been working on that project any further, but it's quite great to see AutoML being able to quickly emit a model and us just focus on building the pipeline to feed in data to it. So it's something I worked on. Yeah, in general, meta learning is quite an interesting field, like the ability to teach machines to learn. That's something I feel is quite important. If you look at the way humans learn, most of us, we either learn by instruction, by teaching, one another supervised learning, or by the reinforcement learning paradigm by trial and error. Being able to teach oneself has some commonalities with what's being seen in meta learning literature right now. So I'm pretty bullish on it and excited to see the progress made on it in the next few years.
Sounds good. So to kind of finish things off, the beauty of machine learning is its strong partnership between academia and industry. The research that academia produces helps inform best practice for industry, and industry often provides a lot of the robust data sets that's used in these big projects used in universities. I see such increased collaborations between research institutes and industry, and I see that being the cornerstone of further advancing machine learning globally, especially because these two institutions have historically been very siloed from one another. But another part, and I see this movement kind of erupting and then taking more full force, especially during the pandemic, and seeing the inherent risks of machine learning is how do we use AI for social good? And how do we help make the machine learning community more aware of social good? And how do we, begin to have these types of conversations? So I just want to talk a little bit about how you invested your time volunteering in the machine learning community and things that you do to help foster deep learning and understanding of both machine learning concepts, and to ensure that AI is properly governed and that the next generation of AI professionals are using best practices when deploying and developing their models.
Yeah, all very great questions. So I'll start with the, what I'm doing right now. So yeah, on my end, I think about quite a bit, because we can see a lot of use cases where, these models can be used for nefarious use cases. So what I spend my time doing with my alma mater actually in India, but also some other universities invite me. I sometimes give guest talks on introduction to machine learning and mostly reinforcement learning. People really like seeing those animations of Atari and then the DQN agent doing really well. So I try to have these talks. More people can find the resources online, right? It's nothing new which I'm teaching them. It's all public information. But I try to get them in at least in my experience university, back then things were still developing and we couldn't really, at least I couldn't really see the broader picture, right? But being able to get these ideas, so just showcase this to young students who are just entering university and saying, oh, this is what's currently going on, this is state of the art, what can you expect to see another 10, 20, 30 years from now. So I've been trying to spend my time giving a few talks, answering questions, and then a few people reach on LinkedIn, we mentor folks. Quite recently, my undergraduate university, they actually reached out to me as a professor I worked with in the past. And he said, oh, cool, we have the research hypothesis on activation functions, but we actually want to get published. What experiment should we carry out? We did this limited set of things we should test. So this is something which I could help. I'm by no means an expert, but I said, oh, you have this function, great. Look at what the other newest activation functions evaluated on, what benchmarks reduce, language, vision, structured data, and so forth. So I kind of guided them high level on what to test out, when it's good enough, what sort of results and all would be reasonable. And then they weren't aware of another thing people are not aware of is archive or the advent of preprint servers, so you can quickly get ideas out there. So I told them, oh, you can wait for 6 or 12 months or even longer potentially for a journal review. But um, if you really want to get your idea out there and like share to other researchers with the caveat that it's not peer reviewed yet, so look at your own risk. You can look at these preprint servers, and then they were like, "Oh, we had no idea about this. It's like, we didn't know we could use archive. And if we publish on archive, can we publish on IEEE later on?" So questions like this were still open. So I was like, so it's really great, like being able to get them to put it on a preprint server, get it out there, and then now these sort of best practices are flowing to other students who are taking the courses. And being able to create this sort of like knowledge sharing, I think is quite important. So ties back to your question, academia and industry, right? So this is what I enjoy personally, but I'm seeing this happen quite a bit, a lot more in the US, and I hopefully picks up in other parts of the world. Universities and top academics are collaborating. Look at NeurIPS, any of these conferences, you see a lot of dual affiliations or people working closely together. So that's great to see, and hopefully this trend continues. On your last question on AI for good, yeah, I do feel that's a very important area, and I do kind of that's why I kind of choose the projects I work on, because we have to be responsible for what's happening next, especially with like pandemics and climate change, and thinking of these broad existential crisis and how we can actually prepare for them best. So I think uh, on a high level, some of the leaders are thinking about these. We started seeing these workshops on AI for good, and then most universities and organizations have their own AI sort of where they think about what projects they want to work on. So I think that's great. One thing, maybe having this done at the university level as well, like encouraging students to think about how they can tackle a lot of social problems using machine learning, and then rewarding them for trying to work on these areas. That's maybe one more positive way to actually make impact on it, make it more sustainable.
Sounds good. Yeah, no, I think the first step is obviously being aware of the problem and then starting to have a conversation about it, and that's when changes begin to happen, right?
Yeah, exactly. Yeah.
Perfect. All right, Praneet, thank you so much. This was so informative, and I really appreciate your time. I'm sure our viewers are going to really listen to your advice, and hopefully it helps them navigate where they want to be next in their professional career, and it also gives them a lot of inspiration on the different avenues and a little bit of insight, because I think a lot of people are aware of the flashy headlines at Google DeepMind, right? But it's also interesting to know that there's so many little niche projects that you guys are working on, and that it's quite attainable to one day be working in a company like that. And so for you to give that inspiration and give it that thoughtful advice, we really appreciate it. Do you have any last comments or anything to say?
No, that's great. That's great. Like, thanks for having me here. And yeah, well, hopefully this helps to folks out there. Yeah, I mean, my one takeaway is like, on a very high level advice is like, just keep working, and then things eventually do pan out. So, yeah.
Sounds good. Thank you very much.